We're going to start with variance and standard deviation. The variance and the standard deviation are the most commonly used measures of dispersion. The standard deviation is the square root of the variance. The variance and the standard deviation are always non-negative, will be zero if all the observations are the same, and will be a positive number if the observations are not all the same. If the values of a group are all near the mean, the variance and a standard deviation will be small. If the values of a group are dispersed from the mean, the population variance and standard deviation will be large. As a measure of dispersion, the variance overcomes the weakness of the range by using all the values in the population. This slide shows the formulas and steps for computing the population variance. The steps are: Step 1, find the mean. Step 2, find the difference between each observation and the mean and square that difference. Step 3, sum all the squared differences found in step 2. And your last step, 4, is divide the sum of the squared differences by the number of items in the population. We show an example of how a population variance is computed. The data represent the number of traffic citations issued during the last 5 months in Beaufort County, South Carolina. On the first step, we find the mean number of traffic citations as 29. The second step is to find the difference between the mean and each of the observations, then square each difference. The third step is to add up all the squared differences. In step 4, we divide the sum of the squared differences by the number of observations to get the variance. These steps are illustrated more specifically using a problem on the next slide. We refer back to the number of traffic citations in Beaufort County, South Carolina, introduced in an earlier slide. After finding the mean number of traffic citations, which we found as 29, this value is subtracted from each of the monthly observed values. Then each of the 12 differences are squared, summed up, and the sum of 1,488 is divided by the number of observations of 12. The resulting value of 124 is known as the population variance. Why population variance and not sample variance? Because the data represent all the citations issued in Beaufort County, South Carolina. Again, the key word here is all. Here we show the formula for computing the sample variance. Note that the steps in computing the population variance and the sample variance are exactly the same except when dividing the sum of the squared differences. For the population variance, the divisor is n, the population size, whereas for the sample variance, the divisor is n minus 1, or the sample size minus 1. Here's an example of how to compute a sample variance. Following the first 3 steps we used for computing the population variance, we obtain the sum of the squared differences as 40. We then divide this sum by sample size minus 1, which is 4, to obtain the sample variance of 10. To obtain the sample standard deviation, S, we first compute the sample variance, S squared, as illustrated in the preceding slide. The square root of the sample variance is known as the sample standard deviation. We obtain the standard deviation of a population in a similar manner, that is, get the square root of the population variance. The standard deviation is commonly used as a measure to compare the spread in 2 or more sets of observations. Let us take the bi-weekly amount invested in Dupree Paint Company, for example. Suppose that the standard deviation of the bi-weekly amounts invested in the Dupree Paint Company profit sharing plan is computed to be $7.51. These employees are located in Georgia. For another group of employees in Texas, the standard deviation of their biweekly investment in the Dupree Paint Company profit sharing plan is $10.47. Let us further suppose that the amount invested by both groups are about the same. The standard deviation for the Georgia group of employees indicates that the amounts invested by them are not dispersed as much as those in Texas, because the Georgia Group standard deviation of $7.51 is less than the Texas Group standard deviation of $10.47. Since the amounts invested by the Georgia employees are clustered more closely about the mean for the Georgia employees is a more reliable measure than the mean for the Texas Group.